So, you brave people who allowed themselves to be electrocuted yesterday. Okay. Kind of ran out of time on that. We will hopefully get that Van de Graaff generator out again towards the end of the term once all the assessments are done. And more of you can have a play and experience the joy of your arm hair going up through electric shocks. Any questions about it? Actually, that would be very good hair to put on the Van de Graaff. Okay, I am going to go through some theory, but I wondered if you had questions. Please let me be able to answer this. Yes?
What assessments do we have? Yeah.
No.
Ooh. Good question.
Do we have a national No?
Okay. That's a very, very good question. Actually, if I should do a criterion D assessment with you.
No, please. No.
Right, all right. Which is a little reflection task.
Oh my.
Like the carbon friend or foe.
No, please, no.
Anything. Anything.
I will do anything. I clean the floors here.
What's wrong with that? What is wrong with a reflection task?
No, please. Anybody
We already have enough reflections.
You do it in the lesson. You can't prepare for it. It's just 90 minutes of writing your opinion. What's wrong with that? Uh-oh, summer's here, the window's open. Okay, look, I've given you a test. You've done criterion B and C. Technically, for IB, I should do a criterion D. Whether we're ahead enough in the syllabus due to the fact I was off sick, even though Anna has been absolutely brilliant at teaching you, whether we kind of run out of time for it. You have to be kind to me. Very kind to me. Okay? I'm not giving you the national test because I think you can do without the stress. Okay? But if things start going wrong, if when I have marked your assessments that I've got here, if I look at your numbers and I think, hang on, you should be doing better, I might get you to do some more. So if the whole class has bombed out on this, yes, you're getting more assessments. If you've done okay, then you shouldn't have any more. But I would probably make it a little test rather than anything else. Does that sound fair enough?
Yeah.
Good. So let's hope they're all right. If I feel that anybody has done badly compared to what they were doing last year, and some people are doing a lot better, other people, you're all grade 9, you've all had stressful times with the personal project and stuff like that. I don't want to load any more stress on you, okay? Now, do not go to the other teachers and say, Karen is being kind and is not giving us any more assessments, so why can't you, okay? I will get into trouble and have to assess you more. If I feel I've got enough to assess you at the end of the year for a number, that's fine by me. But keep answering questions in class or asking sensible questions. Oh goodness, now I'm scared. Yes?
That just like if we're going to have another assessment still, can it be such that like we are able to get plus from that, but it can't like because we have those like sometimes in for example Finnish that we can get like 1 plus 2 pluses or 3 pluses and like so then we don't have to like stress about it, but then if we want to have like the opportunity to be able to like show that we would deserve the better number.
Some of you know you didn't do so well in the test or you didn't do so well in this assessment and therefore you want the opportunity to do something to improve, and I would want to do that rather than add more stress to you.
Yeah.
Okay.
Can it be like that so that then that test couldn't anymore like lower our number?
Well, yeah, but you'd have to be, unless you wrote something really, really stupid, like the electron was positively charged. That would just really upset me. And it would be a very bad thing to write. Who said that? Heathen! Okay, we're going to spend the whole lesson discussing electrons. In fact, we're going to spend a few weeks discussing electrons. Yeah, I hear you. No, it wouldn't. My idea is to try to get the best out of you rather than demoralise you. I'm in the middle of demoralising grade 8 at the moment. I'm not going to do it for 2-year groups. Okay? But you can impress me by showing your wonderful understanding and enjoyment of physics with lots of physics-related questions. Like saying that electrons are all about chemistry. But actually that's right, because in fact electrons are all that determine chemistry. The outer shell electrons go away, I don't want an email. Whereas physics takes on more of the electrons. It can take on all of them, and then it takes on the nucleus as well. So physics in theory is bigger than chemistry. But don't tell chemistry teachers that. They tend to get upset. And definitely don't tell biology teachers that biology is just one extreme little bit of chemistry, which it is. But whereas maths teachers and physics teachers tend to have arguments about which is better. Mathematics is the language that explains physics. Sometimes they don't like it when you say that. Okay. Guys, are you with us or are you just going to chat?
No, where's me? Yeah, this one.
Yeah. It is quite impressive that you got a fairly good test mark, Shine, and you were sat with that lot. Yeah. Interesting. Okay. So, electricity, from which we get the word electrons and many others, electronics and stuff like that. I started off yesterday with a very, very negative comment that I hated teaching electricity, and I realised that might have upset you a little bit. It's not true. I actually hated electricity when I was your age because I didn't understand any of it, and it took me until I first taught it to actually work out what circuits were all about. I just learned everything by heart. I just didn't understand it. And I therefore try to teach it in a slightly different way. We don't do much practical, unfortunately, because electricity practicals generally don't work. And they're really, really frustrating. And I hope that you had the opportunity in PYP or when you were younger to play with little bulbs and motors and wires, yeah? And actually, the simplest bits of electricity where you're putting circuits together, okay, we could do that, but you're grade 9 now. And actually, you're going to point out more that doesn't work than does work. Because there is a world of difference between getting the bulb to light getting the battery, if it's even fully charged, to work. There's a world of difference between that and real live circuits like the wiring we've got here in this room, the wiring we've got in our houses, the wiring you've got on your moped or in a car. And it's really simple and it's good to play with, and then suddenly it gets really complicated and dangerous. And you will be able to do stuff like that. It's probably illegal to wire up your own house here, but you certainly have the potential to be able to do that if you can understand this load of electricity that I'm going to teach you. But unfortunately, the experimental work just is really frustrating. It doesn't work that well. I'll do some demos, and there's so much more to electricity than just circuits. We'll talk about how electricity is generated, electromagnetism and stuff like that. So, what causes electricity? Electrons usually cause it. Okay, what is electricity? It is a phenomenon. I'm going to annoy you by not writing in a sentence. I'm doing an arrow with no capital letter. Sorry. Phenomenon caused by electrical charges. Usually electrons, which are what charge? Thank you. Plus points for you, negative minus points. Usually electrons, but sometimes positive charges like protons or alpha particles. If you wish to be American and sensible, that's ALFA. I'll stick with the English stupid PH. What's happening?
Yeah. My back was chilling. But the one.
Yeah, how to get the younger generation to grow up to be fit and healthy. Make sure you are sitting on really uncomfortable chairs for 8 hours a day. Yeah. Okay. So, any questions about that? I knew someone would say that. Anybody? What are alpha particles? Does anybody know? Okay. These are a nuclear radiation. So they are actually they're a bit of an atomic nucleus that are kicked out, and they're dangerous. Okay, and when we talk about radioactivity, which I'm determined we will talk about, you will learn more about alpha particles. But it's unusual. There is one place probably in your home where you have got them deliberately working an electrical device, and that's a smoke detector. And I will explain more about that later. But basically, they've got 2 protons within them, so that's why they're positive. They've got no negatives. It's the electrons that normally cause the electricity, the electrical current, because they are free to move. They're quite loose in their outer shells. Okay, so it's usually there. Okay, so we learn electricity in 2 types. We talk about first of all, static electricity. Static meaning not moving, stationary. E.g., hair sticking up. We normally think about static as a bad thing. It causes problems. Actually, it's really useful as well. Your photocopied sheets rely on the photocopier using electrostatics to, or using static electricity to take the image. Okay, so photocopiers, inkjet printers, all of them use static in some way. Amazing. And in fact, chimneys are getting, bless you! Chimneys are cleaning up the atmosphere by using static before, well, not letting out the dirty stuff. Okay, hair sticking, it's not moving, hair sticking up. Someone asked the really sensible question, like, why does your hair stick up? So, here we have the happy person attached to the Van de Graaff generator. I've got to draw the Van de Graaff generator now, haven't I? Oh no, what have I started? Right, here is the dome. I enjoyed art, but I gave it up when I was at school. I hated electricity and I became a physics teacher. What does that say about me? Okay. Yeah, only you have to draw it better. You know you want to. Yeah, why not? I mean, come on. It's just, you know what it is.
Yeah, we can describe it. So,
Can't you draw? Come on, you can draw better than me. You don't have to write that rubbish. Okay. So how does this work? Number one, generator creates static. Okay, friction removes electrons from the rubber band, and they move. Okay, now hang on. Let's have they move as number two. Okay, number two, the charge moves onto metal dome and over the person. Number three, here, the charges try to get as far from each other as possible. And that's because of the rule, like charges repel, which is a bit like magnetism. And you know that north and south attract, north and north repel. Okay. So they are able to move further by moving the hair. Yeah. So the hair is, let's say it's covered with negative charge. And it's all repelling. Any questions? Okay, it might not be negative charge. You might be positively charged. In which case, the electrons are actually on the dome thing down here. And atoms with electrons removed have been, or the electrons have moved down this way, and these are positive. You've got missing electrons. Nobody, well, you could test it, but it amounts to the same thing. With static, you don't know if the thundercloud up there is positive or negative, and the ground is the opposite. It's hard to know. The effect is the same. Okay. Now, some of you will have used anti-static shampoo or hair gel or something like that to stop this flying away static business. How does that work? Well, usually it just makes the hair a little bit heavier and glues it down if you've got a hair gel. But if you've got anti-static, the chemicals that are in it, they coat the hair with something that's got a slightly different electrical property, and it doesn't allow static to build up on you. You know how some clothes are more static than others, nylon, polyester, etc., etc. Okay. Now, how does that work in a photocopier? In a copier, you put something that you want to take an image of onto the glass platen, I guess, or a scanner, yeah? And the light goes across and it records the signal that is reflected back. And as it records it, it puts onto a plate inside the scanner an electrical signal, so that, for instance, the dark areas on your image, the light that is reflected back, there's less light of it, it's a dark area on the image, and that becomes electrically charged. The white areas are not so electrically charged. And those electrical charges on the image, on the platen inside the scanner, they attract ink. The ink is very, very fine powder. When the ink is attracted to the plate, and then paper is passed over the plate. And if you've ever had to unblock a printer before it's been heat sealed, you'll know that that ink comes off. The toner, the ink comes off. Then you need the toner applied to it or a heat sealing on it, and it will come out, and the ink won't move. But it's all done through electrostatics. Okay. Now, statics isn't very interesting because it doesn't do anything. It gets interesting if it suddenly becomes current electricity, and that is with an E. I'm sorry if it is not motivating you and you're tired and bored and yawning. Current electricity. It moves. This is moving electricity. Okay. At its simplest, this is a spark. Yeah.
Karen, are both the electricity types, they're both moving, since the static electricity moves onto the metal and then from the metal to your body, to the person?
Yes, you're right, but it stays on your body. Yeah. If you were charged up like that and then miraculously shot out into outer space, it would stay there forever. It doesn't stay there forever when you're in a room like this, because it eventually will leak away through the air. But yeah, static, it stays there for a considerable period of time. Yeah. You can't have static electricity without some form of movement. So even if it's from the friction that causes it. Okay, so at its simplest, it is a spark. So as you loved doing it so much, I'm going to make you draw another person. So What is that? What do you think it is?
Or
It's a spark. Okay, and that's a table. Okay, that's the picture.
What's the generator?
It's gone. This person is insulated. Right, the generator has gone. So this person is charged. Person. And then there's a spark. And then this is Earth. E.g. table. Or me walking past Cheyenne, getting a nice spark off him.
Does the person still have their hair sticking as much up?
This is where I need the ability to put little video on there. As the charge happens, then the hair drops down. Yeah?
But when they're charged, it is sticking up.
Yeah. I can't draw it accurately without sort of a little putting a 2 or 3 bits in the sequence, and you'd hate it if you had to draw 2 or 3, wouldn't you? Yeah. Sorry. I don't know why you guys are so resistant to drawing anyway. It makes your pages more memorable when you look back and revise. It exercises different parts of your brain if you have to draw too. Good. What's spark in Finnish? Sparky. Oh, I don't. Okay. Ah, and is that? That's like an electric spark as well, is it?
Yeah.
Okay. And a spark of intelligence. What a lovely little word. That no doubt has 95 million different forms. Okay, slight exaggeration. So this could be when you're going into a car, you get electric shock. It could be anywhere you get the electric shock. The useless fact is that each centimetre of spark represents 10,000 volts. Okay. Now, the spark happens occurs because there is too much static, and the material between the person and table breaks down, so it can conduct the electricity.
What do you mean when you say that there's too much static?
Let's everybody finish the sentence and I'll explain. Yeah. I'm just thinking about the image to use. Are you familiar with the computer game Lemmings? Oh, you're so young. Do you know what a lemming is?
Animal.
Oh, I feel so old. Yeah. Soft bully. Do you know anything about soft bully?
Yeah.
What?
Well, rodent animals.
Do you know any more about them? That's a lemming. Soft bully. It's sort of it will become relevant, okay, in my silly mind. Now, back even before I was born, there was a documentary, a nature documentary made on lemmings. And everybody of my age grew up believing this nature documentary. That lemmings in the Arctic, they are a little bit weird. They are rodents, and they are very friendly rodents, and they live together in big communities. And when the weather changes, they migrate together en masse.
Oh yeah.
Oh, the one they draw.
And they fall off cliffs.
Yeah.
It's a lie. It's a lie. And I only realised it was a lie when I went up to Kilpisjärvi on a class trip, blah, 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 blah. Met a lemming expert, and he said, no, they never jump off cliffs. That was because this one documentary, it's one nature documentary that was really, really famous many years ago, actually showed loads and loads of lemmings running along, jumping off a cliff when they were migrating. And everybody in the world believed that's what lemmings do, apart from people who live in areas where there are lemmings, and said, that's a lie. And actually it was all set up, and actually they just had loads of dead lemmings that they filmed up close and kind of had them on a rug and shook them and moved them, and then threw them off a cliff. I know! Alternative facts.
Why did you do that?
Part of my childhood was robbed when I found that out.
Never watched the video.
And we watched the video.
Question.
Why is it I get more hands raised about lemmings than I do about physics? Lucas and then Brigitte, yeah.
One last fact, did you know that the documentary was made by Disney?
Yes. Well done! Excellent! Lemming documentary fake, see? Brigitte, yeah.
Why did the film like going off the set like why did they game?
Probably because these little creatures aren't really that interesting. And I don't know, maybe someone just thought, let's have a laugh one day. I am going to get back to the Van de Graaff generator. Again. Yeah, so they're alive.
Another one, Simon, was that when they are massively overpopulated, they tend to go into a phase where they like to spread out and disperse. that all the lemmings banded together and migrated was noted, despite the fact that it is often cited that it was this Disney documentary that started the myth. This is not the case either. There is a reference to huge numbers of lemmings jumping off cliffs from a 1954 American Mercury article, which is a full 4 years before Disney's documentary came out. On top of that, there was a 1955 comic by Carl Barks titled The Lemming and the Locket that portrayed the same type of thing. Animals do as facts. Lemmings are a type of rodent, not unlike mice, muskrats, hamsters, or gerbils. They are typically found in North America and Eurasia and prefer the cooler parts of these regions, like Alaska and northern Canada and
Okay.
North America.
Enough useless lemming facts. Now, there was a computer game.
They feed on leaves,
Shut
nuts, and grasses
up.
primarily.
There was a computer game called Lemmings in the very, very early days of computer games. And that had how many lemmings could jump off cliffs and things like that. So, how does it relate? Okay, imagine that the electrons are lemmings. Okay? Actually, truth be known, when there is a lack of food, they do migrate together. And you do get lemming migrations. Often as individuals, but sometimes they're forced together. And sometimes they have to cross rivers to get to the food. So it looks like they're committing suicide. Okay, so imagine that here we have lemmings. If there are too many of them, they start to turn on each other and they hate each other so much. If there's too much static, there isn't enough space. So what will happen is that these electrons will try to move. Do you remember that zzz noise you heard yesterday?
Yep.
That's the electrons starting to leave the person where the static is being built up, or starting to leave the dome. So actually, before you see the spark, you're hearing the electrons moving. It's the scream of thousands of tiny lemmings going, "Get me out of here!" Okay. Now it's actually the ionization of particles in the air that make the noise. Okay, so it's like the electrons are joining the oxygen molecules, carbon dioxide, nitrogen in there. That's what's making the noise, and they're traveling quite fast to do that, and I think it might be something to do with speed of sound, etc., etc. Now, when there is enough of a pathway, so there's enough ionized air here, the insulating properties, the ability of the material to protect from electricity, actually get broken down. And then a path happens for that spark to actually flow. And that happens at two ends. It happens here where the charged object is, and it also happens here at the Earth. And you might have heard, it's totally true, that lightning, yes, the lightning cloud is maybe a kilometre or so above you, but if you're on the ground about to be struck by lightning, some little electrical feelers start from the ground or start from you going upwards. This is how you know you're going to be struck by lightning. You feel static electricity on yourself. Because what's happening is that this area where the lemmings are is very, very negative. The Earth has got lots of free electrons in it that can move, and it starts to become positive, and those positives start to jump out across. And when they connect up, you get the spark. Yes?
How much time do you have before it strikes?
It could be fractions of a second.
So you just feel it and then you just get hit?
Yeah.
Or just
Yeah, usually you're aware of it. If you're ever outside in an electrical storm and you start feeling your hair going up, get somewhere safe. Hopefully you would get somewhere safe. If inside a building, inside a car, or if you're in a field, just lie flat down.
But if you say it's in seconds, then how do you have time? You
You might have time. I don't know. I believe it could be instant. It's like, actually, if you're quite a hairy person, you benefit from it, because the more hair you've got, the more points you've got for that discharge, and the more points you've got for that discharge to happen, the less likely you are going to be hit.
So if you're bald, you have a lower chance of getting struck by lightning.
Higher.
Higher.
Yeah. No. Yeah, higher, because you've only got 1 point of contact. Your body. You want to disperse it. I think that's right. Yeah. So, if the lemmings, the electrons, think that they can get across safely, they'll jump. So if there's a small gap, they'll jump. So in a spark plug inside a car engine or moped engine, you are deliberately making a spark. So you deliberately, at the top, you all know what I mean by spark plug? No? I know, Dipankar's looking at the clock, there will be a break.
Would you be safe if you went underground?
Yeah, probably. You know what they are? Inside engines, yeah? Okay. That part here is at 1 voltage, it's charged at 1 level, and then the spark jumps across that little gap. And yeah, that spark provides the ignition for the fuel. So that's how the fuel burns. And that gap is really, really important. If it's too big, the lemmings can't get across, so that you can't have the current. If it's too small, it's firing too hard, it doesn't burn properly. The bottom part gets covered in carbon, and then the spark plug won't work. So that gap is really, really crucial. Now, with a lightning strike, we try to edit that gap. It's very, very difficult, but if you've got tall buildings, put great big lightning conductors on them. Because the spark, the lemmings, will try to go across the shortest route. Because basically, these charges, they don't like each other. There's a force between them that's going to make them repel. And if that repelling force is too big, and that equates to a voltage with a little equation. So if you've got a centimetre and you've got 10,000 volts worth of electrons there, then it will jump across. Okay? So with a lightning conductor, which might be attracting 100,000 volts or so, they're hoping that just by having a rod on top of the building, that the electricity will go to that rod. And then, you know, with a lightning conductor, you've got the building here, you've got the rod here, but then you've got a wire going down the side of the building. And sometimes, if it's very, very corroded, or it looks a bit burnt, or it's actually had a lightning strike go through it. And that's how buildings get protected. Any questions? Apart from, can we have a break? Dipankar?
So when the lightning strikes, and it's usually like white or blue color, is it the electrons itself? Like,
the color of lightning is the color is due to the ionization of the gas in the air. So the electrons at that point are passing through, and there's so much energy, it creates a light flash, ionizing the gases in the air. If you had a different gas, it would be a different color lightning. Yeah.
My old teacher told a story where she went camping with some people, like a family, and then they had a lightning storm, and she from the up in the tent side, she could see like multiple colors of lightning, like purple, blue, orange, yellowish.
Wow.
All going.
Yeah. Wow. Well, it's, yeah, different gases produce different colours, but that's weird. I know that, having done a very nerdy experiment, that actually sodium, when it ionizes, it produces an orange flame. And actually, if you look at the spark on your hand or your arm when you're in the dark and with that machine, it actually is orange. as it ionises the sodium down there. No, I'm not doing that for you. Okay, 3-minute stretch break. Phones are not to be used. You are to use other muscles than your thumb before texting.
After the break, can we write that down in more? I want to explain the ionization. Like short,
Yeah, okay. Yeah. Shall I remove the lemming?
No.
maybe.
I'll tell you, when I went up to Kilpisjärvi, we went out for a walk. This was a couple of years ago. And the first lemming I saw was dead on the road. And it had a cut down its abdomen.
A what?
A cut. Like someone had just done surgery on it. Let's choose that one. Okay. So this poor little lemming that was really, really sweet had a cut down there. Okay, well that's a bit weird. Someone destroying lemmings like that. Walked a bit further along the road, another dead lemming. Like 5 or 6 lemmings. And I was with the person who basically, the parent who basically organised the trip, and she was a biologist. She was like, why have these lemmings got a cut down the side? And we couldn't work it out. Then we met this kind of world lemming expert who was spotting the migration. And apparently they are caught by, I think it's Korpi ravens, to eat. And these ravens, like there's so many lemmings around, they are so skilled at taking the best bits to eat. They have evolved to simply use their really, really sharp claws, like knives, to cut down the middle, peck in with the beak, take out the juicy bits, and the rest of it's wasted. Absolutely incredible. They eat the best bits, and then presumably other, like varmis or something comes along and it eats the rest of it. And we'd just seen the remains of this lemming slaughter. Really, really sad. Very sweet. I did get up at 3 o'clock in the morning to watch live ones running across the lake, which was frozen. Yes, I did. I got up, was it 3 or 4 o'clock, just as my class were going to bed. I caught a few of them sneaking into the bedrooms.
Yeah.
Gentlemen, you moved very far. Most of you moved nowhere. Is it comfortable?
Yes.
Kind of. Right. You want me to explain? Light is just caused by, or light is electron movements within an atom. And as the electrons move, they actually move from kind of like shell to shell. Then they give out light. So that's how we get visible light radiation. Often ionization. Okay, come on then. Okay. So, you want me to write something down?
Yeah, no, can you write that just short good notes?
I'm trying to think how to do it without mentioning lemmings. Okay, so light is produced by a spark as the no, just underneath the electrical charges
I don't have space.
Turn over. I haven't asked you to draw the lemming. Be grateful.
You said don't go to the next page.
Did I?
No.
Move through air, ionizing it, or moving the electrons in the air molecules. I hope that is enough.
What did you say the zapping, or the zapping noise was caused by?
That's the same thing,
Yeah.
but less electrons. That's like the first few brave lemmings who jump.
Okay.
Yeah. And then there's a whole flood of them. It was all a lie. I mean, Donald Trump goes on about fake news, but it's been going on for years and years and years. It makes you wonder what else he's been lied to. He could be lying to you now. Electricity doesn't really exist.
Time is just moving.
Yeah. Well, it is. Okay, a bit more about current electricity. So we usually talk about current electricity. This could be a new page, because it's kind of a new paragraph. Okay, current usually flows in controlled circuits. Lots of emails. Wish people would leave me alone. And that's a huge, huge breakthrough. If you think about, well, our world is utterly dependent on electricity. It doesn't bear thinking about what would happen, particularly here in here in Finland, if suddenly our electricity stopped. That would be amazing. Lots and lots of. Without the ability to have an electric circuit, our life would be dramatically different. No lights. Yeah.
There is a bomb or
A bomb.
or something like that called the EMP, I think,
Yeah.
and it can cut off the electricity or whatever from a whole
Yeah.
a big area, and then it could, if that would be launched, then that could basically trigger the end of the world or an apocalypse thing.
Yeah. I'm not sure if that bomb actually really exists. But certainly if you, with now modern warfare, if you wanted to cause the biggest amount of destruction and inconvenience, then take out all the power stations in main cities. Yeah, they're very, very, very vulnerable. Except it would not be a good way to bomb North Korea. Because it's too tiny, isn't it, to see? Don't know if you've ever seen this. That I find one of the most dramatic images about society. So that's the nighttime picture. If you want a developed world, or a developed country which has got an infrastructure, etc., the evidence of that at night, here you've got South Korea, and this is all the artificial light. North Korea.
How do you know that's true?
Because the International Space Station has flown over it so many times that there's so many different photos at night taken of Korea, the Korean Peninsula, and you can see where the money has been invested in an infrastructure.
What's the place that has light?
There,
Yeah.
probably the dictator's palace with a bright flashlight going, "Yay, look at me, look at me, I'm the only person who's allowed electricity." So yeah, there are poverty-stricken areas where there is no street lighting, etc., etc. But it's that image, the Earth by night, is a map of human technological developments. What we now need to move into a different technological era is where there is no light pollution leaking upwards. So, for instance, you've got new LED street lighting that is just directed downwards, rather than just a glowing bulb that sends its light in all directions. So that's the next development. But yeah, there is a population throughout there, but there's no investment in the country's infrastructure. So bombing them with this would be of no use. Cheyenne.
So how does the electromagnetic pulse affect electronics?
Well, it would wreck it, could destroy it. Just if you are looking at an electronic chip, or the electronics inside your phone, is basically lots and lots of really complicated circuits put down on a microscopic level. Yeah. Now, electricity can work at a microscopic, almost nanoscopic level, involving very, very few electrons, causing big changes in circuits. If you make one or two of those electrons go a different way, do something different by firing a great electromagnetic pulse at it, electrons, they move, they interact. So if you then get them to move in a different way in a really delicate little circuit, bang goes your circuit. It's not going to work again. I don't know if you noticed yesterday, I took my watch off when I was going on the Van de Graaff generator. Okay, you don't want to go next to it with your mobile phones. Actually, they're quite well protected. I haven't wrecked a mobile phone with the Van de Graaff generator yet, but I don't want to risk it. So an ordinary circuit like the circuits we've got in our lighting, that you've got real size wires that you can handle and you can move and manipulate. But if you've got a circuit in a mobile phone, a computer, or whatever, then you haven't got a hope of really repairing it if anything goes wrong. Okay, so current usually flows in controlled circuits. You need to know what the main bits of a circuit are. The main parts of a circuit are: number one, the supply of electrical energy, otherwise known as the battery. In Finnish, paristo. What is battery technically? Yeah, it's the thing on the wall. It's the heat radiator. Yeah, okay. So it's the battery, or if it's not a battery portable device, a mains supply. Have you heard of the word mains? Yeah, okay, so that is a wall plug. And there are two, sorry, pause, not go too quickly. Okay. There are two types of electricity that you get. From a battery, you get DC, and from a main supply, you get AC. AC/DC, not just a rock group. Okay? And the battery supply has the symbol long, thin line, short, fat line. Have you met that before? Yeah. And AC is like that. And you don't meet that symbol very often at this level.
What does the AC and DC?
DC is direct current, and AC is alternating. Okay, and we discuss how you get those in when we talk about how electricity is generated, which we will do. So that's direct current. Alternating. Okay, now that supply of electrical energy is not going to do anything unless you connect it up. And for that, it needs a conducting pathway, otherwise known as wires to connect them up, or to connect the parts. If you've got a broken path, your appliance, whatever it is you're using, is not going to work. You might have a switch that isn't on. My computer isn't working. Try switching it on. Oh yeah. Okay. Number 3, components to transfer energy, e.g. lamps, motors, speakers, etc., etc., etc. It's just like a jigsaw puzzle. You have the wires, you plug the bits in, they do the job, hopefully. Okay. Safety devices are also helpful, e.g. switches, turn it on or off. Cheyenne.
Yeah, so how does like Bluetooth connections affect the energy transfer? For example, if the speakers are like wireless, how does it like? Does it? I don't know how to like ask the question, but like, does it really affect the energy transfer, or does it just?
Yes, but less than if you have a earphone wired in. So you've got a little transmitter. That would be the component, a transmitter of the Bluetooth signal inside the phone. So electricity is going to that, sending out electromagnetic radiation as Bluetooth. But that's actually a very low energy thing compared to sending a whole current up a wire to your earphones. Yeah. Yeah.
What do you mean, like, what do the safety devices help?
Right. Well, a safety device, simply to switch it on or off, so you don't have to unplug everything.
Yeah.
And it doesn't waste energy. But the main safety device could be a fuse, in Finnish sulakka. Yeah. So a fuse, and that melts if the current is too high. Yeah. So, for instance, we don't get them very often in Finnish plugs, but there is a little wire in a lot of British plugs. I'm not sure about US plugs. That is a device that you put into the plug, and then if there's too much current, the fuse will actually blow. Now, you've got them in houses. You've got them far more commonly in houses. And the old fuses, they are actually cylindrical, weird devices. Cylindrical fuses. Let me look it up. Yeah. There. Ever seen that?
I'm not sure.
Okay, if you've got an old house, you might not. Have any of you seen those before?
No.
In a cupboard by the front door, believe it or not. It's a fuse. Have I actually got one, an old one? Here, one of these. So, for instance, because I live in a house that was built, I don't know, 30 years ago, in my attic, I've got a little cupboard and I've got a row of these. And sometimes, if the lights go off, then I have to replace one of these. So this outside is a very big insulator, but here the electricity can go through, or it can go in, round and out. And if the electricity is too high a current, that wire inside will melt, and it means that too much electricity doesn't flow through the whole house, and you don't get a power surge that, if particularly in wooden houses, can actually set fire to them. Now that's got a red end to it, because it's got a little bit of foil at the end attached to that wire, and if it melts, then that end comes off. So red is for one size of current, blue is for another, etc., etc. But this is, yeah, I mean, if you've got a new house, you can pass it around if you want, if you haven't seen it. If you've got a new house, you won't have that, because those are old technology. They're reliable, but they're old. What have you got instead? You've still got the cupboard in the end or somewhere in the house. Loads and loads of switches, and you've got resettable fuses. So you don't physically have to take something out and replace it. And a little device has been created that makes this resettable fuse. It actually works with a magnet, but if it's too high, the wire attracts to the magnet and it pulls the switch down. So if your lights go off and you've got resettable fuses, all anybody ever does is goes down and flicks the switch. It doesn't solve the problem. Yeah. Probably what has happened if it's on the lighting circuit is you've got a bulb that's blown, and actually you've got to replace that bulb, or you've got a dodgy connection somewhere that needs looking at. So it is a warning. If you've got a switch that keeps tripping, you should check it. You can now buy quite easily, thank goodness, because they are important safety devices, resettable power supply leads. Now, what on earth are they called? And you should have at least your computer and wireless router attached to it. What's it called? Is that too English? Wonder what circuit breaker is in Finnish. It's better, it's better, it's better. That's the sort of thing I'm looking for. That'll do. Is that US?
Yes.
Okay. You don't have to draw that. Imagine that was just the 2-pin plug socket here. But you plug that into the wall and you've got an extension block, multi-socket here. You've got an on-off switch, but you've also got, well, here you've got USB ports. You've also got a little light on here, and sometimes your power, this will go off because that light has gone off, and that can be resettable. It's like a little trip switch on a power multi-socket. Yeah.
Why do like lamps explode? And why are there sparks if like you plug something in and then there's like a spark?
Okay. Can I answer that in a minute?
Yeah.
Once I've done that. How many of you have got something like this multi-socket which is resettable?
What is
You probably do, but I mean,
It means that it hasn't blown the fuse, the main fuse, but for somehow it will stop working. And then if you press a little button on that device, it goes back on again. No? Okay, I'm not acting as advertising for any particular company, but I would invest in something like that. Circuit breaker resettable multi-socket. Let's they are really useful because what happens with them is that if you get too much current going through one of these, they don't blow the components that are attached to it. Okay, so for instance, when I had a wired modem, I used to run my modem and router through it, so that in a thunderstorm, when you maybe get too much electricity somewhere in the whole system, that it didn't actually destroy the modem or destroy the computer. Have any of you had a computer destroyed in a thunderstorm? One of you? Okay, I've had a modem, yeah. Okay, I wouldn't believe it would happen until I came to Finland. The earthing here must be pretty bad. But yes, if you get a power surge, like in a thunderstorm, or even if there's something wrong with the power station, it is possible that delicate sensitive equipment can stop working. Because electricity, as well as going round the circuit from the power supply, you can also get electricity from earth in the thunderstorm. Okay, so they're a little security device, and I would certainly, well, I tend to run a lot of electrical equipment, so I tend to have quite a lot of these. Right, your question, why do bulbs blow up? They shouldn't, they do. They overheat, the gases inside expand and they might explode, but more LED lights are now more and more reliable. If you had a filament light, like in the digital projector, if I dropped water on it, it would explode due to thermal expansion. Okay, now why do you get a spark when you plug something in? Now, that is interesting. You have on the wall, you have 2 sockets here, and you are going to plug in something metal. So that's the wall here. Really bad drawing. Here's your plug that's going to go in, and there's a lead, and something is going to work there, like a lamp. Really bad drawing, you don't have to draw it. Okay, let's imagine that's plus, that's minus. This is going to complete your circuit. So as this gets closer and closer, those little lemmings in the plus and the lemmings in the minus, the electrons, they get close to each other and they sense that there's a gap. And within that gap, they will jump across. Now, hopefully, that gap is so small that you only see it as the plug comes in or out of the wall, rather than that far away and leaping out at you. If you happen to be foolish and stick something metal inside, it will jump through and then it will jump out at you. So you have got to make sure that you are holding the plastic and you are not holding these pins as you put the socket in there. And actually the sockets here are quite deep, so that it would be very, very hard for you to do that. And every nation that's got its own design of plug sockets has got its own safety precautions there. The US, unfortunately, seem to have the least safe plug socket precautions, historically, yeah. But actually they justify that because they run at a lower voltage than the European. So yeah, we can talk a bit more about that later, but that's why you get the sparks. I'm sorry, keeping you awake. Yawn. Okay. So that fuse melts. Are you in a hurry? You've got 5 minutes. This fuse is resettable. Okay. Any questions? One thing I forgot to say when we were doing the Van de Graaff generator, I told you about the standing on one foot and the dance. But what I did forget to say, and this could save your life, when I was stood with my hand like that, yeah, my muscles were twitching so that my hand went inwards, yeah?
Yes.
It didn't go that way. Your muscles contract. Good. If you ever have any doubt, for instance, you are walking in the country and there is a field full of horses and you want to check if it's an electric fence, you do not grab the fence like this, because your muscles will contract and grip. You grab it with or you don't grab it, but you can touch it with the back of your hand, because then if it's live, your muscles contract like that. Okay? If you are turning on and off a light switch and you have wet hands, you are foolish. You shouldn't ever do it. You shouldn't ever switch on the device with wet hands. But if you are, do not switch the device with your hand going downwards like that. Because if there is any fault in the circuit, it is going to grip, so your hand is going to grip towards the wire. Okay, it's better to do that. Okay, I must admit, as a fairly paranoid, nerdy physics teacher, I rarely switch anything on, like a kettle, using my finger like that. I usually use the back of my finger, because if there's any fault, it will contract away from the source of the wire. I know it feels a little bit weird, but as someone who gets quite a lot of electric shocks, it's actually a very safe thing to do. So yeah, when I attach myself to the generator, I'm not going to attach myself so I grab hold of it. I'm going to attach it myself so I pull away. Okay? Go to lunch, you hungry people.